Yes. So today we're going to discuss functions. Okay, so I think it's not function that we discuss. The next chapter, there is another chapter, chapter 7. Then we will discuss 2 chapters because this is not very long chapter. It's something basic. Then we can go over it quickly. And now we go through chapter 8, which is function, which is very important. So let's start with chapter 8 of the book. Okay, so the chapter 8 is basically about the user input, how Python receives anything one user type. So for example, if you want to user to input anything, we use the function called input, right? We use the function called input, and now we open a bracket and type something like this, which serves as a prompt to tell the user what he needs to do. And now whatsoever the user return will now be assigned to the variable. So this is an input, and you ask the user to type something, and now when the user types anything, it will be assigned to this variable. So here you can see we ask the user to type anything inside your name, and now we print hello. Then you can see here it means the name. It will print the name of whatever it is. So let's see what this will do. So when we type this one, we run this one. You can see here it asks me to type a number, right? So when I say Musa, when I type this, so you can see here it types allows say hello Musa, right? So the main idea is that in Python we use input function to collect anything from the user, but many other editors will not allow you to type input from here. But you can see VS Code we can do with that. But whatsoever you input is a string. So Python, whatsoever you collect from input from in Python is a string. What I mean by this, now look at it here. I said something like this. I call this enter the age, and now I want to print the age. Print age. So here I'm asking the user to input the age. Now when I run, you can see it asks me to enter the input, right? So I say, okay, the age is 5. It's 5 days. When I enter here, you can see now I said, okay, now print the num, right? So you can see here it print the num is 5. But let's look at what is the string. Okay, type of. Can you see num is a string, all right? What I mean by this is that now you cannot do addition of numbers because whatsoever you collect from users is a string. So if you want to change what you receive from user, you can convert it to either float or integer. So now here I can now say, okay, whatsoever I collect here, convert it to integer. So let's see what this will happen. So when I tap enter, now I say, okay, give me 5. Now I say, okay. So now 5 is assigned to number. So let's look at what type of number is this. Can you see it's integer, right? So this is telling us that whatsoever you receive from user as input, then that thing is actually a string. So it is you, the user, that will try to convert that thing from whatsoever, if it is string to integer or whatsoever. So here you can see we ask the user to type an input, and now after the user type an input, it's asking us, and we can type the number, which is 5. Now we convert the number to float. So here we can see that our number is float, 5.0 user. So that is what we mean by input, receiving input from user. But sometimes we use what you call validation, exception handling. So what does that mean by exception handling? So exception handling is the way in which you try to test something, and when that thing is not correct, you will prompt an error. So we have the first one, which is try and except. Okay, this is the example. The try block lets you test a block of code. So whatsoever you have two sections, you have try, and you have another thing called except. So this section, you try a code. If there is an error, then this section will be executed. But if there is no error, then only this section will. So the except block lets you handle error. So let's look at this an example. While true, try this, try num this and break, except values error, print invalid input. So what this means is that while this is true, meaning that you input a number. So let me run this one. While this is true, you can see I input, I run it, now I put 1. So when I put 1, I put 3. So can you see that it now put good job, the entered number is 3, right? So here it means I print the last one, but true here means anything. What we mean by true? If let me type 0, when I type 0, you see, so this is basically try and except. We'll see what this means. So just having that now, this is some kind of block that allows you to run a code when something is true. This will be executed. But when there is error, so let's see something like this. Num divided by 0, right? Num divided by 0. This means that whatsoever we collect, we try divide it by 0. So let me run this one. 5. Can you see it?
Yes.
Because I try to divide by what? By 0, and 0 is, you cannot divide by 0, right? So it means here there is an error. So this is something that we will look at. So multiple input values in a single line. So sometimes you may want to have multiple input in a single line. What I mean by this is, if I have this in Python, I have this A, B, right? I can have something like this. 3 and 4. So this means that when I run this, the first value 3 will be assigned to A, and the second value B will be assigned to 4. So if I run this one, what is A? This means that A is 3. But you see that what is B? B is 4, right? So this is how we do multiple assignments in a single line. So how can we collect numbers or input multiple times from the user? We can use input as well. And now we can arrange the variable we want to assign the number, but we need to use a function called split at the end. So let me run this one. So when I run this, I can say, okay, 1, 2, 3, because I have two variables. So can you see the first one is 2, name is now here, age is now here, score is now here. So now can you see I print this stuff? So this means that this is everything here I print. So that is how you can collect multiple input from the user. So you need to split. So that is basically what this chapter is talking about. This chapter is basically talking about how you can use the function called input to get something from the user. Yeah, so any question before we move to the next chapter? This chapter is just basically about input, and we have seen now how we can receive user input. The most important chapter is chapter 8. Any questions, Saada and Simon?
No question, Doctor.
Okay, so let's go to the chapter 8. So chapter 8 is about reuse function, code reuse. So when we talk about function, it means code reuse. What this means is that, for example, now let's see a motivation number 1. I ask the user to type an input. Now I calculate whatsoever he types. I calculate the square root, right? Now I printed this like this. I say, okay, give me the 5. Now what is the square root of 5? Can you see the square of 5 is 25. So here you can see I ask the user to put the number. I find the square root because to asterisk means square root, and now I output the result. Now, if I want to find the square root of another number, I need to write the same code exactly the way it is. Can you see that? I need to write. So let me ask another user something, but maybe here something like that. I can say this 5. The square of the digit is still something because I'm multiplying. Can you see that? Now, these kind of things are actually cumbersome, but we need a better way in which you can write something that does not actually include much code, that encourage what we call code reuse. So instead for me now, I can write all my stuff that calculate the square root of a number. Now, when I want to calculate the square root of a number next time, I need to just call something, a single line that will calculate the square root of a number by referencing this code without repeating this code. So that is the main aim of function. So let's look at this one here. For example, we can import something called power, which is power from mass class. And now I can say, okay, if we, get the user input, now I can say power this. So what this means is that I don't actually now do the calculation myself or to calculate. I will just call a function that will do this kind of stuff directly. So you can see when I run this, it will ask me the number, for example, 5. Now you can see this is this, right? So this means this power, I can use it anywhere by putting the number, which is, and the power you want to raise. So if here you see, I don't need to repeat writing the code. So that is the main term of what we call function. So we'll see what the meaning. So you can see this power, which is function, you can see what it's doing. So now if you come here, call help, and now call the function called power, it will show you the code behind the power function. Help on built-in function power in module math. What it's doing basically is that, can you see x and y, return x times y, which is power. So you can see here, this is how we can see what the function we call is doing. But now this is just motivation. Let's see how we can create a function and what we can do with it. Okay, depending on the language you are using, function may also be called method, procedure, and subroutine. So in some scenarios, function will be called with these names. And the function are essentially pieces of code that have been packaged as a single unit. So as I was saying here, that when we calculate maybe this square root, we need to calculate the square root maybe different way. So we can package all from one code that calculate the square root, and now just call that code to do that. That is called a function. So let's see, as our program grows larger, function make it more organized and manageable. So when we have a program getting larger, then putting your code in functions actually allow some kind of what we call modularity. So it means you will be just calling some pieces of code from different files to execute your activities. So the first thing we will see is what is called built-in function. What do you mean by built-in function? Python comes with what is called built-in. That is, it means it comes with it, right? It comes with it. You don't need to do anything to create the function. Python comes with it. And the first one, we have something like this, sample integer. Basically, integer take a number and now convert it to integer, right? Float take an integer and convert it to integer. These are called Python built-in functions, right? You can see one thing you should know that in Jupyter, you can see I put float here, string here, but the Jupyter give me the last value, which is string 32, which is it. So this means that Jupyter actually don't output everything. It will output the last item you have. So if I want to output all of this one, I can put like this print. If I want to see everything, I can put print here as well. Print here as well. Print. Here as well. Print. Okay, so when we run this one, you can see we get the everything outside, right? What we are saying here is basically that if you have many code in Jupyter, it prints the last one. So you should know this, yeah. So now that's user-defined function. They come with Python. You don't need to create them. They are there. All you need is just to call them so that you can execute them. Now, and what we can see next is what we call user-defined function. User-defined function is the function that you create yourself that you use in your Python program. How do we define user-defined function? That it consists of different stuff. The first thing you need to use a keyword called def, def, and now this is the function name. And now you open bracket and input something inside. These are called parameters. And the next thing, the next line after this, then you use this column. This is called column, right? You use this column. So def is a keyword. Every function must have now. So okay, there are what we call anonymous function, but the normal function called this called keyword def. And now the next thing is the name of the function. And now you open the bracket and now put the stuff you want their function to do and use your column. Now the next line, we have what we call docstring. These are called docstring. Docstring. What do we mean by docstring? So this docstring, they explain what the function is doing. So I will show you what the essence of this. So you can see I want to do the sum of two numbers. So now here I have a function. Now I will say return. I will use a keyword called return, and now I will sum the two options. So whatsoever I input 1, 2, then I will return the sum. So this thing that I input here, they are called x and y are called parameters, right? Are called parameters, and def is called a keyword. Now, sometimes that is how we take it. That is common to say that a function takes an argument, right? Takes parameters and returns a result. So this function takes parameter x and y and returns the result, which is the summation of this. The result is called return value. So this is called a return value. That is the value we will return. So let me run this one. Let me run this one. So these parameters that you put, these are what you expect your function to do. So now I want to actually sum two numbers, add two numbers, x and y. So I should put this function in the parameters. And you can see docstring enclosed in code, triple code, which Python looks for when it generates what we call docstring. I will show us. Now, so now we create a function. Basically, just this one, we create a function. Now, how can we use the function? So let's have them here. I have a is equals to 2, b equals to 3. Now, for me to call this function and use it, what I need to do is just select two arguments. It will show me. So you can see it's sum. Now, what this function basically does is that it's some x plus y. You can see now it's some x plus y, right? So this section is called function call. It's called function call. We are calling this function. Yeah, we are calling this function behind the loop. We are calling that function to do the sum. And a and b are called arguments. A and b that we provide here to the function call are called argument. But here, x and y that we use while defining the function, they are called parameters. Sometimes you can see that it's a bit, people use them interchangeably, but strictly speaking, what we have during the function definition, that is we define the function. Here we call function definition. So what we have at function definition, they are called x and y, and they are called parameters. But when we supply something inside during the function call, these are called parameters. So let's see what is the meaning of that doctrine. So you see when I have this add, now I call this, I call that doc. So let's look at what will give us. So you can see here, this function is called what? Add, right? It's called add. But I have something here which actually tells what the function does. So this means that even when you give this function to any other person, you write a very complex program, he will try to say, okay, what this function is doing. Then he will try to obtain the docstring of the function. So when he runs it, can you see add? I now call something dunder, doc, dunder. it displays the docstring. So you can see docstring is very useful and it allows you to know what the function is doing. But it's not necessarily, right? But as a good practice, we put docstring to explain what the function is doing. So you can see an argument is a piece of information that is passed from a function call to a function. So this A and B are called argument. Not people often sometimes speak interchange these two argument and parameters. So just, yeah. So let's look at another function called greet. So you can see we use the def keyword, we use a function name called greet, and now I have open braces. So you can see here, the function does not have any input, right? Doesn't have any parameters because it's just printing what we call hello, print hello. So it does not take anything, it just do print it. And this is our docstring. So that docstring can run multiple lines, not only one line. So you can see here I have docstring, and now I have everything here. I put it, I explain what the code is doing. Now I can now do printing. So now when I run this, I can call the function. So you can see this is called function what call, right? This is called function call. When I run this, it will be called the what is here, which is hello. Now also when I turn this print greet the dog, it will tell me what actually the function is doing, which is called for yeah. Any question before we move on? So this is another function we define, def. This is the function name, upper and lower, and now it has a parameter called a string. This means that we'll input something. So, but what does the function return? Whatsoever you type, which is string, it will call a function on top of it, upper, which will change everything to uppercase, and again it will call lower, which will change it to lowercase. So we have an example called banana. So you can see here I call the function test word. I now put this test word, which is banana, right? Let's look at what will happen, right? Can you see? You can see because this return function return two things, right? What it return? The first thing it return is the uppercase, right? The second thing it return, it is what lowercase. This means that whenever I call this function, it will return two items. So what it return, I now assign it to uppercase, right? Because the function, the first thing the function return is uppercase. The second it return is lower. So whatsoever it return as second, I assign it as lowercase. So you can see when I run this, it will give me uppercase and lowercase. So this is called a function, and this is how we define a function. Any question before we continue?
No.
Mala?
No question.
Okay, Mala Masara, any question?
No question, Doctor. But this function, can we call it an object?
Sorry?
Object
Yeah, so everything in Python is object.
is object.
Yes, in Python, everything is object. So this notion of object, we'll talk about it in the next chapter, in the last chapter, which is classes. You will understand a lot and you will see that, oh, this is what it means by a function. So the most confusion part is the class, and you'll understand more about the class in the next chapter. So let's go on. So, yeah, so this is, we know what is defined. So define a function, it means this is this is function definition. We define a function, right? When you see, let me define a function, this is defining function. But when you see call a function, this is calling function. Here you see I call a function. Pass parameters. This is, we are passing parameters to the function. Argument, you know what is argument, right? So argument is these parameters, these are the parameters you pass. So these are some of the stuff you will be seeing later. Now there are two things regarding to the function. We have what is called positional argument and versus keyword argument, right? Positional argument and keyword argument. So let's look at it. You can see here, I have a function called greet2, and now I have something parameters, number one num and this number two, right? And now I call for I in the range of num times, put in this and hello and then. So what this means is that I now have two parameters, name and num times. And now I use a for loop to go into the range of the number of times I give to print hello name. So Simon, what do you expect this one will give us?
Hello Musa 4 times.
Eh?
Hello Musa 4 times.
Okay, so let's run this one and see. So we can say, okay, hello Musa 4 times, right? Because we use for loop inside, right? It will now, this is a function and this is it. So because now we call the function and you can see we put Musa and now 4, right? So this kind of thing is called positional argument. What this means is that this is the position of this you call it here. N times this you call it is positional argument. When you change this one, orders matters. What we mean by orders matters. So in positional argument, you can see I just call this because this is string. That is why I call it here together with string. But because this one is the num is integer, I said for num in num times, which is integer. What about if I actually change this one from the name is imputed here and the name times imputed here? You see there will be a problem, right? So that is what we mean by orders matters in positional argument. You can get unexpected result if you mix up the order of the argument. So you can see here, I put 4 here and num here. When I run this, it will give me an error. So this is mean that the position we need to do, if you look at this one, the position of the first argument we know is in string. You can see here, the position here num times we know is integer, that is why position. So this is what we call positional argument, and orders matters always, right? But we have what is called keyword argument. So what this means is that in keyword argument, remember this is the function, right? This is the function, remember? This is the function, right? So you see in keyword argument, what I need to do is I need to call the name of the parameters. You see I say name equals to Musa. And now I call this one num times equals to 4. This is called keyword argument. That is, you need to call it. So this one you can see, I can run it here. If you are using keyword argument, the orders actually does not matter. That is, I can write this num times in the first, right? And the name in the second. So if I run this one, this actually doesn't matter. It will give me the word. So because this variable, I already assign it to 4 and this one. But when I use positional argument, it's actually a problem it will give me. I'm sorry, Kingani. Okay. So yeah, so that is this. So now it does not really matter which calling style you use, as long as your function calls produce the output you want, just use the style you find easiest to understand. So for me, the style that is easiest to understand is keyword style, because like you put whatsoever so that it's no confusion. But you can also combine the two different kind of argument, right? You can combine the two. So you can see here, the first one here I use positional argument. Now here I use what? Keyword argument, right? Keyword argument. So when I run this one, you see this, and I can run this one, because here you can see I say name equals to Musa. You can see this is keyword argument, right? But the last one I use what? Positional argument. So this one can also be fine. What I did. Okay, yeah. So this is something that I want to show. So in Python, you can see here, I say it's okay, it's totally fine. You can actually combine the positional and the keyword argument, right? So this is positional, this is keyword. But in Python, whenever you want to combine the two, positional and keyword, positional argument must come first, and the last one, then you have the keyword argument. So you can see here, I have keyword argument, then positional argument. This is wrong. Python will not run this one. So always, you need to change the listing of the argument must be in this way. that is positional, then keyword argument. If you have this, we don't. Default value when writing a function, you can define default. Okay, yeah, so that is what they mean by this. So error, positional argument follows keyword argument. Can you see what the meaning of that? Do you understand this one?
Yes.
Yes.
Okay, let's move on. So there is also what we call default values. So there is something called default value. What is the meaning of default value? Now here, I want to define a function called grid2, right? Now here I put one name, but here I put the value num times 2 equals to 3. It means I put the default value I want the function to use. So this is called default value. If you remember this one here, when we define the function, we just say name num times. We don't know how many times we want to print out, right? But this one here, you can provide the default value you want the function to run. So this is called num times. So when I run this one, what would give me this one? Who can tell us? What this one will give us? Mother?
Yeah.
What this will give us?
It's going to run 3 times.
Okay, 3 times. Okay, let's run it. So now here I run the function, right? Now I want to call this function grid, but now I input only name argument Musa, but this one, even if I don't put this default, when I run this one, it will use the default value that is times 3. This is called default argument, but I can override it, right? I can say, okay, I can call the function grid num equals to Musa, num times equals to 5. I can override this num times equals to 3. So when I override it, I now call the function, it will now use the new value. But when you don't supply the new value, it will use the default value. So that is what we call default value in a function argument. Avoiding argument errors. So how can we avoid argument errors? So for example, this is my function. I now have two argument, right? But now when I come here, I want to call 2 argument, I just call 1 argument. Then you may see an error. Can you see that? Add missing 1 required positional argument. Why? So you can see this is telling you, you only give the X value, which is 2, but you didn't give it. So let me say, okay, let me give the second value here. When I run this program, it will give me the expected value. Can you see it give me 5? But when I put 2, I run this, it gives me an error. So this is what we call argument errors. What we mean by argument error is that you don't actually specify or give the required argument. And this is what we call traceback. Traceback actually tell us where the error is. You can see it will tell us the type of error adding method, and it tell us the function where the thing error occur. So you can see now it tell us the function, which is the add, it tell us the function, the where the error occurs, and now it will tell us the argument we are missing. Yeah. So, and this kind of error is called traceback. And you see, yeah. So any question before we continue?
No question.
Okay, return value. So what do you mean by return value? So in Python, function actually don't necessarily return values, but you can specify the output and the return statement for your function to return. So let's look at this example. We have what we call get for method names, and this is first name, this is last name, right? And now this is what we call, what do we call this statement? Who can tell us? What do we call this?
Doc. For doc. That is the doc. What do you call it? Document is something.
It's called what?
Doc something.
It's just like documentation, a doc string.
Yes.
Doc string. Okay. Now this is doc string. So now here I declare a function called get for method name. I have two arguments. Now here I say, okay, full name. I said F, which is used to concatenate full name, last name, it give me, and now I have a return value, which is full name dot title. It means it will change the title of the full name to whatsoever. Now here I have get formatted Musa Isa, right? And this means that whatever it means, this function will return everything that it return, it will assign it to the value Isa. Now when I run this one here, you can see give me Musa, right? So what this is saying that when you call a function that return a value, you need to provide a variable that return value can be assigned to. This is a good question. Whenever you call a function that returns value, you always need to specify a variable in which what the return function return will be assigned to the variable. So this is the main idea. So because this function called get formatted returns a value, which is return this full names, so we assign this the value. And now here I print the value. Can you see Musa Isa? Okay.
What's the difference between the previous ones you've been doing and this one?
Which one?
And this one that you are assigning student equal get formatted something. Can't you just call the function get formatted and pass the arguments just like that?
Okay. So this is so for instance, I can call this one here. So is it what you mean? I just call this. Right?
Yes.
Okay. So when I call this one,
what's the difference between the two?
Yes, I get the output, right? But what if the output I want to use it in some part of my code?
Okay, I understand.
Right? If the
yes,
output of the function, I want to use it in some other part of my code. So always remember, yeah. So for example, remember when we are doing from sklearn, yep, for linear from sklearn, for example, from sklearn, right? So from sklearn, remember, you can see here and import now this is the function. I can now say, okay, I will consider this whatsoever is now linear regression. Can you see? Can you see I call this linear regression and now assign the result to X, right? So we will see this thing in today. So this, I import a function called linear regression. Now I create this object and now assign it. So it means we're gonna use something. So that is the reason why that when you call a function, you can see that when you call a function, now you assign the value to another variable that you will use in the future.
Yeah,
okay, we have what we call none in Python. So Python has what we call non-value in Python. That is would represent actually the absence of a value. So one example is a print. So print actually it does not return a value. So this is an example of function because you see the print actually does not return a value. It just output this one. So when I return this one here, you can see it's hello, right? But when I assign the output of print to something called spam, the output of print, I assign it because it does not return a value, it returns hello and none. So when I return this, I run this one. Let me see, okay, what is the value of spam? What is spam? So this one here, yeah, so you can see here, the spam is none. It does not return anything. But you can see I can do something like this, compare with it. It's none equals to spam. You can see it's true. So what we are saying that is some kind of non-value you see that may be used for comparing, but don't care about that. We see it more detailed in the future. Let's move on. Optional argument. So there is something called that it sometimes may make sense to make an argument optional so that using the function can choose to provide extra information. So some argument may be optional. So here, let's see an example. Here I have argument parameter, first name, middle name, and last name, right? Now I call full name, first name, middle name, last name, right? Now I call a function called return to return this one, right? Now I now call a function called get formatted. I call the function, I put the input. Now I print it. So you see here, it will give me the names of the musicians, right? But sometimes someone may have only first name and the last name. Maybe he does not have the middle name or first name and the last name. He has two names. So you can see here, this function cannot work for people with the two names, right? So here we said for you to create that thing is we need to create optional argument, optional parameter argument. So how can we do that? So here I call the same function, first name, the last name, and the middle name, because the middle name may be optional for other people. So when I call middle name, I impute this in empty here. Can you see it? Here is empty, right? It means, so if middle name, it means I now test with something. If middle name, that is if user impute anything, because if user impute 3 items, it means the middle name is available. So anything integer is true in Python. So remember, if we have this Isa, Kamini, what will be the result of this one? What will be the result of this one?
Where?
This one. If we
Isa. Isa is to. To how will I know? Where did you get that, Isa? From line 8 here? That is our previous work.
Kawai is a string. I want to compare this string with the value true. Are they equal? It's just string.
Say the kai. I cannot say because string and
Isa.
because one is boolean, one is string. So they are not going to be the same.
They are going to be the same? So what about if I do like this? No, this is not exactly the what I want to show. Okay, let's continue. This is, I don't have a perfect example. So what I'm trying to say here is that, no, I need to show you this example. Okay, so yeah, okay, this I explain it here. So what we mean by this is that I have first argument, second argument, and another argument which is middle name, and you can see the middle name is what, empty. So now I want to say, okay, if the middle name is available, print with 3 names, but if no middle name, print with only 2 names. So if middle name, it means if this is true, so anything that is non-empty is true in Python. Anything that is non-empty is true. Do you understand the statement? Anything that is non-empty is true in Python. So this means that if a user types anything, then this will prove with the 3 names. And now they will turn this one. But if there is no middle name, then it will use only the first 2 arguments. So this is what we call optional arguments. So you can see here, I now call 2 items, 2 arguments. Now let's look at it when we run. Yes.
If there is no middle name, can we write none?
Can we write what?
None. First name, last name, and none.
Here?
Yes.
Oh, okay. So what we want to use is that we want to use this single function to represent, to use 2 things. If there is middle name, to print with the middle name. If there is no middle name, to print without the middle name. So it means now here that when we have two names, 1, 2, 3, it means there is no middle name. Then it will use this else part. It has two things. It will receive always, the function will receive three items. If it receives 2, so here that is why I say if middle name, that is if the user input middle name, it gives 3 names, then print first name, middle name, last name. Else, it means there is no name, that is for there is no middle name. Then print only first name and last name. Do you get it?
Yes.
So when we run this, can you see we have 2 items? It gives us Jenny and this. But you can see here I have 3, right? 1, 2, 3. It means there is middle name. When I run it, this one, it will give me 3. Can you see that? So this means this is what we call optional argument. Optional argument. So another example. So let's look at optional argument in print function. So you see print function is inbuilt function, right? Print is an inbuilt function in Python, right? So when I run this, you see the first one print is here. The second one print is here. But what is actually taking print to the next line? Let me show you what is happening. So if we call this print with docstring and look at this function, look at it. Then it means print has a default separator and it has a default end line. What this means that it has 2 arguments which are default. The first one is what? End line. It means when I call print function, it will automatically go to the next line. It has a default and it has a default separator which is empty space. So let me show you something. Now, hello, right? Can you see hello? Now in the print, I use end. I now input empty. Don't go to the next line because by default, this is a default argument in what do we call it? Default argument in print function. So it means if I put this one, it means let's see what will happen. Can you see hello, wall? That is the 2 things does not actually come to the line. So this means that this one, this is what is used in Python. This is the print function has this thing by default. So when I run this one, no. Can you see that? So the print function has this thing by default that this is next line. This is telling you next is a next line. But we can change it to anything we like so that it does not. So this is just to show you you can use this dog to see what the functions are doing. So also by default print, when we use print, here it will do this in print. When we run this one, what is that one? It's not running. It seems the program is not running. Okay, let me see. Okay, you can see here I have the print cat, dog, mice, right? It means it's printing cat, dog, and mice. But why is it printing spaces? It means in print has a default separator, which is a space. Can you see? This is a space. Can you see like a space? This is a space. But I can say, okay, don't use default value. Use this thing. Use this one. I can show it. I say, okay, use this separator, which is this. Can you see? Separator, I say use comma. So when I print this one here, you can see this is different from this one and this one. Do you understand what I mean?
Yeah. It's like Canada breaking the internet detachment. Okay.
Okay. Can you hear me now?
Yes.
Okay. So
Maybe
yeah,
it's my internet.
okay. So the next thing is function inside another function. So you can use another, you can call function into another function. What we mean by this is that you can have another function to call another function. So here I have a function called return stars, and now here I have another function called print start, centered start, right? So this means that this function, what this function basically does is this. So when I call this function, I call it return stars. I give it like 5 times. What this function will do is that it will actually return stars 5 number of times. So, but I want to print centered instead. So maybe I want to print something in centered, but the star will be in center. So I say, okay, print centered star. This is a function, and now it has an argument, the line 46, and now I have a string. I call a star here, return star, which is this function. Now I impute something like this, which will give me some kind of number, length, which is 46 minus length of string, that is the string you put here, modulo 2. So whatsoever it means, give me, you can now print this star string, and string, whatsoever you put. So let's run this and see. So you can see this one, it gives me stars here and stars here and the hello world. So this is basically just an example. Don't get confused. You can go through it. It's just to tell you that you can call a function inside another function. That is the main idea. We are not here about the technical here. You can go into it. So returning a dictionary. So we can return a dictionary from our function. So let's look at it. Here I have a function called build person. I have a person name. I have the last name. But now I want to return a dictionary. So what I can do is that I create now a new variable called person. Now I have a person. Now I say, okay, whatsoever the user put is a person. And now whatsoever user I put now is the last name. So now I assign it to be a variable called person. Now I return that variable person. So this means that when I run this function like this, so when I run this one with 2 items, what this will give me is that when I run, it will return this. So you see first name. What is the first name? Jimmy. As the last name is Hunter, right? So this is how you can return a dictionary. It means you can create a dictionary to be returned from a function. Does that make sense? Any question?
No.
Okay. So what will this one return? Who can tell us? What this will return?
Tony, I'm not saying your question.
Eh?
I'm not saying your question, so I don't know what you're asking.
Ah, this one.
Oh, okay. Yeah. Okay, person is this magic. Age is age. Okay, return person. Okay. Okay, it's going to return first name, last name, and the age of person. But if the person does not have an age, that is, if age is none, person age is going to be age. So if the person did not enter age, then the dictionary will be age equal age, or age colon age.
So here it means, like you can see, we said age is known. By default, age is known. There is no age, right? So we said person is equal to first name, right? Last name. So this is the thing. But if age, that is if user input age, then we update the dictionary. This is the age in the dictionary is now we update the person, because you can see we create a dictionary called person. Now, how can you add a new value to a dictionary? This is how you add a value to a dictionary, by calling this stuff and using this and assign the value. That is how, and now you will return a person. So you can see here now when I don't input the age, now here, for example, when I don't put the age, I call this one only. Can you see it does not actually, because age is by default is what? None, right? It will not return this section, right? It will just use this one and return it. Any question?
No question.
Okay, let's move on. Using a function with a while loop. So you can use also a function with a while loop, which is basically the something what we said. Yeah, this one is also something arbitrary argument, right? Okay. Not this one. Maybe this is not. We have not. Maybe the arbitrary argument is at the later. Let's continue. Passing a list. So you often useful to pass a list to a function, whether it is list of names, numbers, or complex number. So here, example, say we have a list of users and we want to bring a greeting to each other. The following example send a list of name to function. So what this is telling is that we want to have our. Okay.
Just one. Hello. Hello.
Yeah.
Thank you.
Okay, can you see?
Yeah.
Okay. So what this is telling us is that sometimes we may need to pass a list into our argument, not like just some couple of stuff. So we can do that as well. So this is an example. Here you can see we have a function called greet users, because we want to put a list of names of people that actually greet them. So you have the function called greet users, and we have the name here. So now we can see here, we say for name in names, this means that these names that we impute is a list, right? It will now, okay, hello, name.title. That is the first name in the list. It will now print the message here and now go over. You remember it's a for loop. It will now go to the next name in the list. So if I have impute this list, the first thing now, if we go for name in names, that is for name. The first one is Hannah. It will say hello, name.title. That is, it will change it to capital letter, which that is the name of this title, and now print hello Hannah. It will go up until it's finished. So this means that we can impute list as our argument in as our parameter in that. And now here, when we want to call a function, now we can call it with a list. So let's run this one. What do you expect this one will give us? Look at that.
Now the hello Hannah, hello TY, hello Margot, all in proper case.
Okay. Yeah, so you can see it. Yeah. So that is what we mean by this. So there is something called modifying a list in a function that we can see here. This is also another thing, an example that you can modify a list. Okay. Modifying a list in a function. So what we mean by here, when you pass a list to a function, the function can modify the list. Any change made in the list inside a function body are permanent. So here is an example. Consider a company that creates 3D printed model of design that users submit. Designs that need to be printed are stored in a list, and after being printed, they are moved to a separate list. So you see, this is an example. A company that create 3D print model of design that users submit. So users submit a design and they create a 3D, and design that need to be printed are stored in a list. If a design need to be printed, they are stored in a list. But after being printed, they are moved from a separate list. So here, what we mean is that we want to create, modify the list. So here is an example. I create a list of design frontiers, robot implement, this is this, and now create another list called completed model. So this is a list of the that we have, and this is the list of completed model. So we want to use a while to actually go through this function, this stuff, and try to do some stuff. So let me show us here. We said here, while unprinted design, now here is the unprinted design, right? Which is a list. We have current design. We want to create the design that has been done. Unprinted that pop, it means it will pop the top one. So it means maybe it has been designed, and now we add it here, and now here we have completed model, which is empty list. Now we append what we already pop. That is, we pop this one, it is now inside current design, and now we append it into completed form. And now this is a while loop, it will go over. The next one is this robot, it will now pop robot, and now assign it to current design. And now current design will be allowed to current completed model. The next one is on case, it will be pop, and now the output will now be assigned to current design, and now it will be at you can see. So now completed models. Now when we go into this, now when we call completed models will contain the list of models have been completed. So let's run this. So you can see here we have this. The following models have been printed for complete model in completed models, because this is completed model, print completed model. So this is it. Yeah. So this is something that we can actually change the list in our stuff. So let's we don't have much time. The time is we have a few more minutes. Let's look at passing an arbitrary number of arguments. So you see there, we see that you can pass a list, you can pass 2 arguments. But what about if you don't know you don't know in advance that you want to pass 1 argument, 2 argument, or 3 argument? The first thing you need to do, you use what you call this. Can you see this star? So this means that you are imputing unknown number of arguments. Maybe it can be 2, 3, 4, 5, 6, 7, 8, 9, 10. Unlike the previous one we saw, you need to define, when you define a function, you have 2 parameters, 3 parameters. So here now I define a function called make pizza, right? When I define the function called make pizza, it means that I don't know whatsoever. So this means that I can use this one. When I have this, when I run this one here. Now I have this. So you can see this one is with 2 arguments, right? It will now print. Can you see it will print toppings? What are the toppings? It means you can see here when you have this asterisk here, it will print whatsoever you put here. So you can see here now I say make pizza. I now input 2 items, right? I input 2 items. When I run it, it will return the items, because that is what it will print. The function, what the function did actually is print whatsoever you input. Can you see that? So also when I have 3 items, it will still print them. So when I have 3 items, you can see here, it will print them. Can you see them? So what the main idea is this: when you don't know in advance how many parameters you have, then you can use this what we call arbitrary number of arguments. That is when you don't know that. Yeah. Any question?
No questions.
So note that Python packs the argument into tuple. So what this means is that whatsoever you input here, Python, the output the Python will output is a tuple. Can you see that? It's a tuple. You can see this is a tuple. This because you can see tuple is surrounded by this, right? So what we mean by that is that when we have this function, and now we call the function that has this arbitrary, the output will be a tuple. So you can see the asterisk is the parameter name. This token tells Python to make an empty tuple called toppings. So when you have this, you put 1 star and toppings means you are telling the Python to create an empty tuple, right? Called toppings. And now when we put this one, we impute this one will now be put into the empty tuple. So note that Python packs the argument into tuple. So even when you have a single item, it will have a tuple. Can you see this is a tuple? Remember I said that a tuple, even if you have one argument, one item, a tuple has a comma. Do you remember this?
Yes. Yeah, what I wanted to ask, does that mean you cannot modify the output of this scanner?
Yeah. So, okay. Yeah. So yes, exactly. So yes, but you can convert it if you want to modify it. You can now change it to a list. So here I can say, okay, this is a list.
Oh, okay.
So if I want to work with it and modify it, I can now. What is this? Okay, it's not iterable. Let me see.
Maybe you can, okay. I was thinking like if you can pass it to a variable and then we now convert it.
It's still the same thing.
Okay, okay. It's still going to be the same. Yeah, it's still the same.
The list, okay. Okay, so what we are trying to do is trying to change this, right? Change a tuple to list. What can we do to change? That is how we can convert a tuple to list. I don't know what is. Yeah, that is basically how you can convert a tuple to list. I don't know what is happening. Okay, let me see something. So, for example, if I have this, I have maybe this is a tuple, and I call this. I can look at it. It converted it to tuple. It converted it to list here. But why this one does not do that? Okay, let's see what happened. Let's see. So here we call our function called. Now?
Like what we have is bracket. Supposed to be square bracket. Oh, that one will not affect it.
Which? Let me see. This is. What am I doing here?
So I already come up with a function.
Okay, what is the function? The function is
it should be from the function, whatever you will change.
Make pizza the function, right?
Yes.
Okay. 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 So so let me change it. So here is a print. So let me say return. So look at this one, right? So here, let's look at it. So when we call this one a list, can you see it?
Yes.
Yeah, because here I'm using print. It's not returning the list. Do you understand? It's not returning. It's just printing, you know. So that is why, yeah, it's not working that way. So that is how you can convert a tuple to list. So also, as I said, even if it is a single item, it is a tuple. This is a tuple. Maybe Malama, you are not there. So when you have a single number like this 2 in Python, this is a tuple. This single number is a tuple. A is a tuple. So if you do like this, type, and you see what is the type of A? Type of A is, can you see tuple? But conveniently, it means here they can put bracket like this. Therefore, a tuple. Yeah. So when I return this, this is a tuple. So what this is telling us is that a tuple is identified by this comma, by this one, by this comma. So this is a tuple. So I may not have necessarily the closing bracket. The closing bracket is just to show that can you see it's a tuple? So even if you have a single value, then you need to put this one. That is what it is. So you see here, it shows that this is the tuple, right? Yeah. Any question? So yeah, so that is what we mean by that. That we can use that one. So more on this unpacking operator. So this star is called unpacking operator because it unpacks a tuple. But it can be used for many other things. We will allow us unspecified number of elements. So you can see we use it to allow unspecified number argument, and we will work on list to unpack element to tuple. We can use work on a list to unpack element to tuple. Can be used to unpack and match 2 lists and many things. So let's look at them one by one. So here I have one list. I have another list. So when I call list, this list A star, what this means will be like, so I have this, when I run this, you can see this is a list, right? But now I change it to what? To a tuple. Yeah, it now changes, it unpack. That is called, it is called unpacking operator. It unpack it from a list to a tuple now, right? That is one of the function of this. We'll work on list to unpack the element to tuple. Can you see that? We have seen the first one. We'll work to pass unspecified number of element argument. We have seen that previously. Now we are seeing we come on list to unpack element to tuple. Can be used to unpack and match 2 lists. Can also be used to match 2 lists. So here I have A already. I have this. So can you see I have this A? I have this. So now this one I can match them in this way. So this will match this 2 lists to a tuple. Can you see that? So this is also one of the function of unpacking operator, can be used to unpack and match 2 lists. So you can see it now unpack the list first, which we see here, and now it match again the and can also the iterable object you will get using the unpacking operator is not a list but a tuple. So this is what we have seen, that what we can get is not a list but a tuple. We can use the keyword list to change it, the tuple to a list, but yeah. Yeah. So here, this is the same example we saw, but here we have like a toppings, we have the size, more or less is something as the one we see, yeah. But sometimes in Python, you see like it has something. People, if they have the argument that contain multiple arguments, you use what is called args. Star args, it means it accepts multiple arguments. So here, instead for me to write a function, I will just write args. I will just write args. It means this collect many input. But here, because I'm using something like pizza, that is why I'm using toppings. Yeah, so in Python, you see people are using args, star args. It means something, this is something like this, but they prefer to tell you in this way. So using arbitrary keyword. So that's the first one we saw now is using only arbitrary parameters, but what about arbitrary keyword? So what we mean by this? Now, some people, sometimes you see these quacks, 2 star, not 1 star. So what does that mean with 2 stars? So it means 2 star, you can give an arbitrarily key value, that is A equals to 1, can you see B equals to 2? But the previous one we see, you just give like A, you give 1, 2, 3, 4. Look at it, let's look at it. Can you see the previous one here? Write the example. Yeah, so here I have this toppings, I have unpacking operator. Now I just call the item 1, 2, 3. But if you want to say, okay, A is equals to mushroom, B equals to green paper, C equals to, then you use what is called double star, not one, which is called quarks, which is called keyword, for short, quarks, keyword argument. Quarks, it means keyword argument. Quarks, quarks. Can you see quark is a keyword argument? So this means that now we don't know in future how many items we're gonna use, but we can use these quarks to actually know it. So here I say, okay, my depth sum quarks, that is keyword argument. I have a variable I declare 0. Now I want to iterate over to the value for x in quarks.value. So remember, if you have values, you are actually taking the value, not, for example, remember in dictionary, if we have a dictionary like this, if I have a dictionary, or this, yeah. So for example here, B equals to this. So now remember here, if I say B dot values.
Mountain is not a dictionary, is it not?
Yeah, it's tuple.
Cool.
Naga on the line.
It's not a dictionary. We
Yeah,
are supposed to use braces for dictionary.
Oh, yeah. Sorry.
And then not equality, colon.
Yes. And here must be here, right? Okay. And yeah, let me use a simple example. So you can see here, I have a dictionary. When I run this one, I have, if I say B the values, yeah. So if I call values on dictionary, it gives me the values here. Can you see 1? Can you see 2? Right? Can you see 3? Right? It gives me the values, right? So also if you are using whether it is tuple, if you call values, it will give you the values. So here it means now I define quarks, which is keyword argument, something like this, but I don't know how many I have. But now I say, okay, for x in quarks that value, that is the first value that I give, result plus, okay, this is, you remember this is the same as this, right? Result plus, this is shorthand, one of the last one, then I can return the result. So what this is doing is that it's just trying to sum the values in the keyword. So for example, now here I have this example. This is an example, A equals to 1, B equals to 2. Now when I call this function, which is my sum, the first thing is I declare a result equals to 0. Now it will say, okay, for x in quarks that value, that is the first one, the value here. The value result equals to result, that is the original value is 0 plus x, that is the first value, x is 1. Now it will go back, can you see that? 4, because it's for loop. The next value, x in quarks, is 2. It will now say, okay, now original result that you 2 plus 1, now it will return the result. So what will be now the result? What will be the output of this one now?
It's going to be 1 plus 2.
It will be 1 plus 2.
Yeah, so you can see we have this.
Why is it going on?
Okay. Yep. So
Unexpected keyword.
yeah, so that is using of quarks. So this is also another example. I have first name, last name, users info. So this is an example where it collects user info if the user can input the user info. So you can see here, I have like a dictionary called user info. So this one is user info. which is somehow a kind of dictionary. So user give first argument called first, and this one is last. So now I assign first name equals to first. That is I update whatsoever username info given, and now I update with the last name. So when I run this one, this will give me okay. Now I call this function build profile. Now I give a var in Einstein, location Princeton, physics, right? So this means that you can see first, last are given here, first, last, right? This is first, last. But location equals to Princeton, field equals physics. It's something that I impute from this user info from this app. So what do you think will be the output of this one?
What did you enter? Albert Einstein. Okay. It's going to be Albert Einstein. Yeah. Then location, Princeton physics.
What do you mean by
spelled?
Yeah, but the first one here, it will just print Albert or what?
Yes, it will print Albert.
No, it's not. It will not print Albert only. Look at the code.
No, Albert instant. Okay. Yeah.
Remember the code. We have user info, which is a dictionary, because when you have this arg, it means it's a dictionary. Now, I now update the dictionary with first name equals to first, whatsoever we put. I'll update the dictionary with last name whatsoever. So who can tell us?
Okay. So the last one in this is
first name equal to first. It's going to be first, last, then Princeton physics.
But this is a keyword. It's a keyword. Remember, it's not like you are putting a dictionary is something. So let me run it. Look at what will happen. Can you see location, Princeton, field is physics? It will start putting the default one.
The last one.
First name, because I update is first, is the name. Last name is the Einstein.
I did not understand.
Eh?
I did not understand.
Is
it because of the updates? No, what my expectation is first and last name should come first, but then.
Oh yeah, yes, exactly. So
they are coming last.
Yes. Okay. Yes. So what is happening is that user info already come with these values. Already they are. Can you see you already done? Then it means they are already here. Remember dictionary, if you update the dictionary, the thing that you update will come at the top, at the last. You remember here we are updating the dictionary. We are assigning something. So let me show you this. So assume we have a dictionary here. Yeah, exactly. So let me see. So here you can see I have A, right? So when I run A, I have this. So now when I want to update the dictionary, so maybe I have A, I say, okay, I want to add something, which is, for example, C. Okay, no, D. D is equal to 4. So this D equals to 4. I have it here, D equals to 4. Now, when I call A, where do you expect to see D?
Last.
Last, right?
As the last element at the end.
So can you see D at the end? So this is also the same thing.
Yes.
The dictionary comes by default with location is Princeton, field is physics, but you are updating it with the first name here with the last name. So they should be at the end.
Okay, so right, I understand.
Yeah, so that is what that means. Yeah. Yeah, this one we saw it. So the last one here, which is the most important, let me quickly go through it and we can go. Now we have now seen how we can define function and use like even this on Python. Question? We have now seen how we can define a function and use this on Python operators. Now let's look at something. Function allows us to structure our program. So function basically allow us to structure our program. This means that function allow us to put actually make our program in structure format. But we can also go step further to instead to have multiple functions in our function, we can store functions in separate files and now call those functions to our program. Now, when we save a function to a file and now call those files are called modules. So a module is any file that contains function. A module is any file that contains a function. Let's see an example. So for example, now I have a file here. Let's make a module contain a function called pizza. Can you see make pizza? Let's make a module that contains the function and save it in pizza.py. So this function, can you see? You remember this function, right? As this is a function called size and toppings, and now here it outputs. So when I run this one here, maybe not this one here. Well, okay, let me just go back. Okay, so what this function does, if we look at it here, is that if I can make pizza, so what will be the output of this function? Who can tell us?
Okay.
16.
A 16-inch, making a 16-inch pizza with the following, with pepperoni.
Okay, okay. So let me run this. Yeah, making yeah with problem. So let me see that sometimes if you write many functions in a program, they will make your program more complex. So the basic idea is this: take this function, then go and create a file, empty file. I now create a file called pizza, and now paste the function inside. You now create a file, but the file must be .py. And now you paste the function inside. Now, when I paste the function, so what will happen is this: when you call the function, so what will happen is this. So you can see now. I now remember. Yeah, this is what happened, right? When I call this one, so this is our. So now, when you save the function, now that function is that file, because the file contains a function. This is called a module. This module is called pizza. It's called a module, pizza module. So what we can do here is we come here, when I want to use this. So instead for me to have several functions in my program, I will just go and save them in files and now call the file. So I can now import the module. I can say import pizza. Now when I import the pizza, now I can say, okay, the pizza, I can say pizza dot, no, pizza. So when you import the module, I say import pizza. Now you say pizza, that is the name of the module. Now you call the function. What is the name of the function inside this pizza? Look at it. What's the name of the function? Can you see the name of the function is called what? Make pizza. So what you need to do is just call, you need to use this format, but before it is used, put the module name, then dot, name of the function. So when I run this one, let's look what will happen. Can you see it give me the same output as this one?
Yes.
So this is how we import the module. But this line tells Python to copy all functions from the pizza module, from pizza, and put it here, but we don't see it. So it means import pizza from the name import pizza, the code one code in the pizza. Now this is how we use it. So you can see now this approach makes each function in the module is available. So this approach, so if I have maybe 1 million function inside my module, where is the module for pizza? If then they are now all available inside the so also you need always format. So this is the format always if you want to call module name and the function name. Module name, what is a module name? Pizza. What is a function name? Make pizza.
Make pizza.
Yes. So when Python read this, you can read this. So this is the format module name and function name. Can you see module name and function name? So this approach importing makes every function from a module. So when we import this import module, it means I import module. So this means that when I have 1 million functions inside this module, they are now imported into our Python environment. They can be used. This means that the first approach here to import makes every function from module available in your program. If you use this kind of import method to import the entire module, name module.py, each function in the module is unavailable. So it means it's available. So this is another example. Import Numpy. So we have Numpy module, you remember in our program. So now when I have this, A equals to list, now I can say, oh, this is the name of the module, Numpy. I can say Numpy, because inside Numpy, I have a function called sum. So I can call sum here. Can you see, do you understand what I mean?
Yes.
So when I call sum here, it gives me the sum of A's. Can you see, I import Numpy. Or when I call another function, not sum, I can call another function, which is power. A power this, it give me A power 2.
Yes.
Or I can call another function square root. When I call this function square root, it can calculate. This means that
149.
Yes. So this means inside the module Numpy, there are many functions. Remember, this is something that you can install. It's not that I created. It's Numpy. It's a module that is available that we install. So this is an example. But here, if you don't want to import all the functions, for example, here I don't want to import sum, power. I want to import only square root function. There is a way to do that. The way to do it is this way. You said from pizza, that is the module name, import then the name of the function. From, this is the format, from module name, import function name. So this is it. From pizza. Remember my module is called pizza, right? Pizza. Can you see? From pizza, import pizza. Yes. Now, so in this way, when you want to call the function, you just call the function make pizza, you put it here. Or like the previous one, when you only import the module, you need to write the module name dot function name. But if you import the function, you import it from pizza. Kana cewa daga pizza, import make pizza. Kawai ka ce daga pizza, kawai ɗauko mun make pizza wannan function ɗin. Amma wannan approach in ka ce import pizza, ɗauko in pizza gaba ɗaya. So you need to, so if I use this approach, it means I don't need, so I can just call this function that import this way. Can you see it give me the same thing previously? So also here, I can say from Numpy import sum. So when I say from Numpy import sum, it means I'm importing only sum from Numpy. So in here I can use sum of A and it will give me.
Yes.
Yes.
Okay, then the next one is using a as to give alias name. So sometimes you may have several functions. So maybe you, if you say from Numpy import sum, maybe in your program you have sum in your program. So when you import, there will be a conflict between the function you import and your sum in your program. So you can create alias, which is some kind of synonym. So here you can say from pizza, import make pizza, but as NP. Can you see? Therefore, here NP is alias to make pizza. Instead for us now here that I say from pizza, import make pizza. I will always use make pizza here, the function make pizza. But maybe when I import make pizza inside my program, there is a function for make pizza, and that will be a conflict. So I will use another thing as to create alias. That is called as, so you can see from pizza, import make pizza, but as MP. So here I will be using MP. Can you see it? So I will use MP instead of make pizza to complete. So when I run this one, it will now use the something, the same idea. Can you see that? So the something here, import numpy as NP. This means that NP is alias. So you can see here, I can say NP. Can you see dot sum? But because here I don't actually import the function, here I import the function from pizza, import make pizza, but as NP. So I call NP here already because I just have the function. But you can also do something like this, import numpy as NP. That is you import the module as NP. So you can say NP dot, because you don't actually import the function. You only import the module numpy, but you say call the module numpy. You can say NP dot sum, and when you run this will give you this. I don't know if this makes sense. Any question?
No.
Madam Asari, can you go?
Na gane, Doctor.
Okay. Yeah. So what about importing all function in module? So that is the last one, importing all function. Oh my God, importing issue. So here we can use from pizza import star. When you use star, means import komai da komai. But this approach is not recommended. Yeah, because you may actually import everything into your program. So it's not recommended. Then you import what you want to use. Yeah, so this is, yeah, so that is, I think we can stop here. Maybe we can finish this local and some small stuff tomorrow.
Okay.
Yeah, any question before we go? Okay, so we see tomorrow. I think I'm continue with the session.
Okay, thank you, Doctor.
Thank you very much.
Thank you.